7.5 का. A school theatre has 20 seats, 120 seats. The theatre manager planned to reserve some seats for students and some seats for non-students, say outsider. A student pay $4 per ticket and non-student pay $8 per ticket. The school has a rule that at least twice as many seats, for the student have to be reserved as a seat for non-student. In order to maximize the profit, how many student seats should be reserved? Okay, this is the question. It means it's a real world problem. Okay, we have to take this constant, then we solve that according to this plan. Step 1. Let student is equal to x and non-student equal to y. And objective function of particle for student is equal to $4 and particle for non-student is equal to $8. Now objective function objective is profit, so P is equal to $4 x plus $8 y. These are two variables again, x and y, student and non-student, two variables. Next step, problem constraint. In mathematical form, what was the wording? Wording was altogether they have 126 in the theatre. So x plus y less than equal to 120. And second is 1. Second is how many students? Two x more than equal to y. Twice student and this y. I think it should be 2y. Okay, it is 2. Now we have two equations that we have to solve this. In step 3, from 1, x plus y less than equal to 120, split in two parts, less than 120 equal to 120, say 1 is 2. From 2, if x is 0, y is 120. If y is 0, x is 120. These are 2 points, 120, 120, 0. Sketch first. Again 0, say 50, 100, 150. T1, T2. T1 is here at 0, goes up 120. Say it is the point, and here is this is the point. Join all these points. This is x plus y equal to 120. Okay. For shaded area or bounded region, or you can say open or plan towards origin or not, test point. Test point x y equal to 0 means 0 0. So here 0 plus 0 less than 120, 0 less than 120, true? True or false? True. So shaded area towards origin. Again, it is toward origin, including boundary line. Including boundary line. Okay. Somebody is talking, please. You can leave now. Now from 2, it is x more than equal to 2y, x more than 2y, or x equal to 2y. Say it is 3 and it is 4. From here, x, y, again 0, 0, again 0, 0, and we need some other point. Let say x5 or x10 or y2, say y1, x1. Okay, it will be difficult. So let point 10, 10. It will be when x is 10, y will be 5. And when y is 10, x will be 20, x will be 20. Okay, these are points. Sketch a test point. The first sketch the graph 0, 50, 50, 100, 150. Again 50, 100, 150. So y side, x side, y side, x side. 0, 0 is 0, and x10, y5. So it will be almost here. And if x20, y10, x20 is here, 20 is here, y is 10 here. So this will be the line. This is the again shaded area. Test point. Graph A, graph B. Test point 0, 0, 0 greater than 0, meaningless. Let 1 point. 1 greater than 1 greater to false. This means shaded area above the line, not toward the origin, away from the origin. Again, in next step, overlap these two graphs. Origin 50, 100, 150. x-axis and on y-axis 50, 100, 150 is what first graph is here. It is 120. And here say x plus y equal to 120 and x equal to 2y. The shaded area is here. These are the vertices 0, 120. Okay. How we can find these vertices? By solving these two, this one and this one. Again solve x plus y equal to 120 and x minus 2y equal to 0. Subtract 3y 120, y is equal to 40. Okay, y is equal to 40. For x coordinate, put this value here. X will be 40, 120. X is equal to 120 minus 40, that is 80. X is equal to 80, and vertices will be 80 and 40. So this is required 80 and 40. Okay. So this is required. Now last point, last step. What is it? Substituting objective function. From objective function here we have f00 is equal to $4, 0, $6, 0 is 0. F0 120 is 40, 6 120 is equal to 0 to 720 $. F80 40 is 480 plus 640. It is so 32 $, plus $40. Altogether it will be $560. So best option is students would be 80. Student would be 80 and non-student उससे पूछा ही नहीं है, non-student 40. Sorry. But the answer is this. So best option is this combination, 80 student and 40 non-student is the best option. Okay, thank you very much.